Any teenager with a quantum computer would be able to tap into, the crown jewels of
Wait,
any
wait.
security
Misha, I
company.
try to log into my own bank account. If I get the password wrong 3 times, it locks me out and I have to call in to get reestablished. So how is it that a quantum computer can get into my bank account by testing a billion, zillion, squillion passwords, and I can't because I mess up, I got fat thumbs 3 times in a row?
Well, if you want to break into a computer of a bank, the first thing the computer asks you for is to factorize this number. This number has maybe 100 digits. And how long will it take you to factorize a number with 100 digits? A few thousand years. With a quantum computer, you could do that with the flick of a dial. If you have a password of, let's say, 6 digits, how long would it take for a computer to go through every single one of those 6 digits?
This is my point. When I mess up 3 times, I'm locked out for an hour. All right. So why do I believe that it can blow through a bajillion, squillion attempts and then get in? Why should I believe
Because
that?
this is not how the average person gets into a site. This is how the banks monitor who comes into the site. This is what the big boys do when they start to talk to each other. They don't use these little passwords.
That's
they use
under the hood.
factorization.
It's under the hood. Okay. So, all right. No, but maybe it's not that the CIA will go out of business or all security will go out of business. It's that we came up with this security protocol knowing it was out of reach of traditional computing. So surely there's another security protocol where quantum computing would take 1,000 years, isn't there, or not?
Well, so far, the highest level of security is done by factorization. Okay.
No, but
that's how banks talk to each other.
it was invented because we knew it was hard for computers. So
Right.
you're smart. Come up with something else.
What would come after factorization? And what would be? Here's a better question: how would I stop a quantum computer from getting into my stuff?
Right.
With a gun.
Okay. But this is America. We're going to stop you at the front steps.
That's the most,
No, so
that's the most patriotic answer you can have.
wait. So, Michio, it just seems to me we have smart people out there. They come up with some other task that would be damn near impossible or forever task even for quantum computing. There's bound to be something, right?
If you could find it and patent it or copyright it, it'd be a rich man right now.
Okay, because it's the early days, right?
You realize the world economy, it rests on the answer to this question. The world economy.
Oh wow.
Okay.
You could break into anything you want if you had a way to get around some of these protocols.
So now we know what the real motivation for this race is.
Yeah.
Now
It's
we know
money.
what it is. It's money. It's
money.
He who rules the quantum computer rules the
Rules
world.
the world economy. That's right. Rules the world economy. Right?
That's crazy.
That's why people work on it. That's why he wrote the book. Hey, look, this is coming very fast.
This is your book, Quantum Supremacy. That's the title of your damn book.
Yeah.
Quantum Supremacy.
That's right.
How quantum computing will change everything.
Everything. Wow.
All right.
How is quantum computing going to be used to help solve the climate crisis?
Oh, I like that.
That's a really great
Good one.
Yeah.
Michio, what are we not being able to compute that quantum computing will do for us? Will it make better weather models? Better climate models?
That's one thing. Realize that when you model the Earth, how do you model the planet Earth? You divide the atmosphere into cubes, and then you calculate the weather in each cube, and then you average it over the entire Earth. That's how you calculate the weather of the future. Now, how big is each cube? Each cube is several miles across. Now you say to yourself, what? If each data point is a few miles across, you can't trust any of these results. And that's the problem.
Well, that's because something could be happening at the edge of the mile,
right.
and they'll average it into where you are, and it won't apply. Okay,
Yeah.
so that means you want smaller cubes in your
Smaller
model.
cubes, that's right. That's where quantum computers comes in, because they are infinitely more powerful. The things that they manipulate are not zeros and ones for each 10-mile cube. No, they are infinitely small. And so now you begin to realize the power of this technique. We're going down to the molecular scale. We're going down to a scale that is unreachable with digital computers.
Wait, so Eeyore was ahead of his time. Do you remember Eeyore?
The
Eeyore
donkey?
from Winnie the Pooh, the donkey. I think it's Eeyore. He has a cloud that's raining just over him.
Yeah.
So whatever the weather modeling, the cube is small enough to just affect the donkey and nobody else. That's the kind of weather precision you're talking about here.
Right. And when a hurricane is about to hit Florida, they have all the projections of where it's going to hit landfall. And then you see all the different kinds of trajectories. They're way off. They're way off. And these are the best computers that we have.
Wait, in all fairness, they start close to each other and then they diverge.
That's right.
Over time.
So how
Right,
reliable
right.
is that? Right. With a
Right.
quantum computer, you should be able to get much, much better numbers because of the fact that each cube that you're averaging over is not 10 miles across, but maybe
Right.
a few feet across.
Wow.
And my favorite Trump joke ever was that Trump only got interested in climate change and weather when he found out that they model that the hurricane used European models.
That's actually a good joke.
That's a good joke.
That's a
That's
good joke, yeah.
I don't take credit for that. But so, Michio, why the Europeans had what different computing power or different ideas about how weather systems would operate relative to we here across the pond?
Each computer program has a different way of chopping up the Earth in terms of cubes. And then within each cube, using equations to model the weather in each individual cube. And then lastly, to then wrap all these cubes together to get the weather of the entire Earth. That's a lot of assumptions. That's a lot of models. And
Right.
that's why we can never predict the exact path of a hurricane. You see that every time.
I just wouldn't have thought that a continent would have its own set of models relative to another continent. That's all. That seemed kind of provincial to me.
Well, you got it.
The Euro model.
Digital computers are very provincial.
All right, Michio, it's great. We got your book out, Quantum Supremacy. Audacious of you to title it that. I mean, I don't want that to be true, but we know that's what it's about.
Yeah.
We know. We're just being
That's
honest.
the name of the game.
Yep.
That's the name of the game.
Better than the Bourne supremacy. Good for
Oh,
you.